We talked about how a scalar is just a number. So if you see the word scalar, that just means we're talking about some number. A vector is a list of numbers. And so that's just two vocabulary words so that we can draw the distinction between them. If we ever say size of a vector or dimension of a vector, we're just talking about how many numbers are in that list. If we talk about the magnitude of a vector, the length of a vector, or the norm of a vector, all three of those are just synonyms. And we calculate that sort of using the Pythagorean theorem, right? So the norm is just the square root of all of the little entries squared and then summed up together. We talked about how velocity of an object is often a vector because velocity tells us about the speed and the direction. But if you're ever asked about the speed, you just have to take the norm of a velocity vector to get the speed. Because the speed's kind of like just the magnitude of velocity. We talked about how your textbook has an alternative notation for vectors that's not really used anywhere else outside of your textbook. And so I don't like using that notation, but it's important to know, I guess, with the little angle brackets. We talked about unit vectors. So a unit vector is just any vector whose norm is 1. And if you want to normalize a vector, what that means is you're going to try to find a vector that has the same direction, but you adjust the magnitude of the vector to be 1. And so the formula for doing that is right here. We use the notation where the normalized vector has a little hat. So this is v hat. It's just saying I'm taking the vector v and I'm normalizing it. And the formula for doing that is you just take every entry in your original vector and you divide it by the norm of v. So first step is you have to find the norm of v, and then after that you just take every entry and you divide it by that norm. And so our example was I gave you this vector u, where u is the vector 3, 4, and then we found the norm of u ended up being 5, and so u hat, my normalized vector, was then 3/5, 4/5. Does that make sense? And then what else did we say? So there's a bunch of different types of norms. The only one we care about in this class is the one that we've already talked about. So we're going to kind of ignore all the other norms. But every single norm, including the one we're going to work with, has these 4 properties. So a norm is always greater than or equal to 0. So if I ask you to find the norm, it should never be like -5. And in a lot of ways, a norm is a lot like just taking the absolute value of a vector. In fact, if you were to take the norm of a one-dimensional vector, what would that look like? So let's say I have this vector, and it's just a one-dimensional vector, so it has one entry, and let's just say it's 42. And then I ask you to take the norm of this vector. We would say we're going to take the square root of 42 squared, right? Which would just be 42. What if, instead of 42, what if my entry was -42, right? So I have a one-dimensional vector v. The only entry in my list is -42. Well, then the norm of this vector would be -42 squared. And so I would do -42 squared, and that would be some positive number after I square it. And then when I take the square root of that, we, by convention, just keep the positive. So the norm of this vector would still be +42, right? And so in this way, it's kind of like just taking the absolute value, but we're sort of generalizing that idea so we can take the absolute value of vectors. Okay. So we talked about these properties. The norm is 0 if and only if every single entry in your entire list is 0. Because if you have any entry that's larger or less than 0, it's going to end up giving you a positive norm. And then this fourth property is called the triangle inequality. And we talked about the reason this works is because the straight shot across, from one point to another is always going to be a shorter distance, a shorter length than if you take any sort of other path to it, right? So that's how we end up with the triangle inequality. And then the last thing I think we said before we ended it was this. If you ever see lowercase I, J, or K, those little lowercase letters refer to these standard unit vectors. So I is 1, 0, 0, J is 0, 1, 0, and K is 0, 0, 1. I kind of skipped over this a little bit last time, but if you had the vector, let's call it V is 4, 5, 6. And then I ask you, what is 3V? Of course, 3 is a scalar. V is my vector. And so this is what we would call scalar vector multiplication. And what you do is you just multiply every entry in the vector times that scalar. So this resulting vector would be 12, 15, 18. Does that make sense? Yeah. So if you see, 5i, that would be the vector 5, 0, 0. What if you saw 42 times k? What would that vector be? 0, 0, 42. Okay. Another thing I skipped over last time is if you see this, say I have a vector u and I have this vector v. If I ask you what is u plus v, that would be negative 1, 0, 1 plus 4, 5, 6. And so then we just go entry-wise down the vector. We say negative 1 plus 4 is 3, 0 plus 5 is 5, 1 plus 6 is 7. And so the vector u plus v is going to be that vector 3, 5, 7. So vector addition hopefully works exactly how you think it would work, element-wise. So subtraction works the same way. If I said I have u minus v, that'd be negative 1, 0, 1 minus 4, 5, 6. And negative 1 minus 4 would be negative 5. 0 minus 5 would be negative 5. 1 minus 6 would be negative 5. Okay? Yes?
Do they have to be the same dimension?
Yes. If you want to add or subtract vectors, then they would need to be the same dimension, right? Okay, so example. Find a vector with magnitude 5 that makes an angle with the x-axis of 2 pi over 3. So let me draw a picture. Here's my x-axis. And what I'm saying is my angle is going to be starting from the x-axis, going counterclockwise like we always do. And then I'm going to draw this vector like so, where sort of the length of this vector is length 5.
So we are in 2D? Working in 2D?
Yes. Yeah, in this case, it's going to be two-dimensional. If I wanted you to find a three-dimensional vector, I would have to give you like 2 different angles. I'd have to give you an angle theta from the x-axis and like an angle phi from the z-axis so that you could actually locate it in 3D space. But in this case, you only got 2 pieces of information, so this is going to have to be a 2-dimensional vector.
Or it can be,
It's a good question.
like in 3D, it's going to be a cone.
Yeah.
It's
Yeah. You've probably already been exposed to this, but you know what spherical coordinates are?
Yeah.
Okay, yeah. So I would have to give you the full spherical coordinates if I wanted you to find a 3D vector. But we'll talk about that soon. We will eventually talk about that. Anyways, my angle theta is 2 pi over 3. My magnitude is 5, and so I'm trying to find basically what are the x coordinates and y coordinates of the tip of this vector, where the little arrowhead is. You know, what is the x value here, and then what is the y value? So this is just a trigonometry problem, really. My x coordinate is going to be the cosine, right? Cosine of 2 pi over 3 times 5. And then my y is just going to be the sine of 2 pi over 3, again times 5. So, what is cosine of 2 pi over 3? Negative 1/2. Times 5. So that means this is going to be negative 5 over 2. And then what is sine of 2 pi over 3? Yes. That would be square root 3 over 2. And so I'll write 5 square root 3 over 2. So you'll probably see a question like this. This is how you do it. If you're given a magnitude and a direction, you can figure out the sort of the coordinate list form of the vector. Okay, let's do one more. It says find a vector with magnitude 4. This time making an angle with the x-axis of negative 3 pi over 4. Okay. So here is negative 3 pi over 4. Since it's a negative angle, that's why I'm going in the clockwise direction. The magnitude of this vector is going to be 4, so that's going to be the length of my little arrow. And once again, this is just a problem of figuring out what is the x-coordinate of the tip of that little arrow, and what's the y-coordinate of the tip of the arrow. So the x-coordinate is once again going to be cosine of course times the magnitude of the vector, and then the y-coordinate is going to be sine times the magnitude. Okay, what is cosine of negative 3 pi over 4? Negative root 2 over 2. And then times 4 is going to make it negative 2 root 2. And then what is sine of negative 3 pi over 4? Yeah, it's negative root 2 over 2 again. And so once again, after I multiply times the magnitude of my vector, I have negative 2 root 2. And so that's it. Does that make sense? Okay. Then, suppose u, v, and w are 3 vectors that each represent a directed line segment. Okay. Together, these 3 directed line segments can be arranged to form a triangle. Then what is u plus v plus w? Let me draw a little picture. What the problem is saying is that if I take these vectors u, v, oops, sorry, draw it like this, u, v, and w like this, and what I should have said is tip to tail. That's important. if you can take these three vectors and arrange them tip to tail so that they form a triangle in this little cyclical triangular pattern, the question is, what is u plus v plus w? What happens whenever I add all of these vectors together? So,
How is V
Oh.
oriented? What's the orientation of V?
it's like this. That's the head of the v vector.
Yeah, because U plus W is V, and adding another V is just 2V.
You're really close.
Well, it's 0.
It's 0. Yeah.
Yeah.
So, so that might not be completely obvious. The answer is 0, but let me try to explain why this is the way it is, because this is an interesting question. Let me try to explain. If I just had any three vectors like u, and let's call this one v, and this one like w, okay? What it means to add these vectors together is that I place them all tip to tail, and then I draw another vector, a new vector, from the origin all the way out to the tip of the last vector. So this green vector would be u plus v plus w, okay? So kind of whenever we arrange these three vectors tip to tail, and we say that it forms a triangle, meaning that like it gets linked up again to where it started, what we're saying is whenever I take this vector u, adding it to v, like taking u plus v, just means that I start with the vector w at the tip of u, and then I add on the vector w like that. And then whenever I want to add on this vector v, I just place it tip to tail like that. And if I ended up where I started with, that means I have no net movement in the plane. I just ended up where I started with. I've moved 0 distance from where I started after adding up u plus w plus v. And so that's why we say the answer to this question is 0. It's kind of a strangely worded question. But anyways. Next example says 3 forces with magnitude of 400, 280, and 350 newtons are going to act on an object at angles of negative 30 degrees, 45 degrees, and 135 degrees, respectively. And it wants you to find the direction and magnitude of the resulting force. And so in physics, we call this a free body diagram. So in a free body diagram, in a physics class, you're going to draw your little object. And then we're going to draw the forces that are acting on this object, okay? So the first one is a force of 400 newtons that is acting at an angle of negative 30 degrees. So negative 30 means I go 30 degrees in the clockwise direction from the x-axis. And so I'm going to write, I'm going to draw this little vector like that. And then switch colors. I've got another force that's acting with 280 newtons at a 45 degree angle. So I'm thinking about something like that. And then lastly, I have a force that's acting with 350 newtons at the 135 degree angle, which is over here in this direction. Whoops, that should be 350 newtons. So what I want to find in the end is the direction and magnitude of the resulting force. This is going to be kind of a long problem to work out. what I'm going to have to do is I'm going to have to find the components, the x and the y component of all three of these forces that are acting on my object here. And then I'm going to add together those three vectors. And then I'm going to have to find the norm of that resulting vector and the direction, right? And so what we're going to do here is, I guess let's start with the red one. For my red vector, this x value is going to be 400 times cosine of what? Negative 30 degrees. And what is cosine of negative 30 degrees? Root 3 over 2. Okay, so it's going to be 400 times root 3 over 2. Now, the y value is going to be 400 times the sine of negative 30 degrees. What is the sine of negative 30 degrees? Yes. Yeah. Negative 1/2. Okay, so that's my red vector. And then we're going to take that and add to it my green vector. And the green vector has magnitude 280. And angle 45, so what's cosine of 45 degrees? Yep, root 2 over 2. And then what is sine of 45 degrees? Root 2 over 2. Okay, so that's my green vector in component form. And then lastly, we've got my purple vector, which has magnitude 350. And angle 135. So what is cosine of 135? Huh? Yeah. Yeah, so that would be negative root 2 over 2. Because it's 90 plus 45.
90, 45.
Yeah. And then the y coordinate, of course, is going to be sine, which is positive root 2 over 2. Okay. So at this point on your exam, you're going to say, I'm going to pull out my handy-dandy TI-30 calculator, which I have right here. And then we are going, oh, this one's out of batteries. So you're going to have to use the calculator, right, to add together these things, because otherwise it's not going to turn out very nicely. So in this case, you can go ahead and report it to me as a decimal whenever this happens. And so somebody add together 400 times root 3 over 2 plus 280 times root 2 over 2 minus 350 times root 2 over 2. And you can go ahead and round to the nearest whole number.
Did you want the top number?
Yes.
That would be 296.91.
Okay, we'll call that 297. So we just added across the top entries, the first entry on each of the vectors. Now we want to add together the second entry in all three vectors.
That would be 245.47.
245? Okay. Yeah. Okay, now this is my resulting vector, But my question is asking for the direction and the magnitude of the resulting force. Right, so this is a perfectly good force vector, but I actually need to know the magnitude. Well, the magnitude's pretty easy, right? We're going to call this, I'm just going to give this vector a name. I'm going to call this my vector v. So the magnitude is just going to be the norm of v, which would be the square root of 297 squared plus 245 squared. So what is that magnitude I'm looking for? You say 385?
Mm-hmm.
Okay. 385. And then I'm looking for a direction, and the direction is going to be in the first quadrant because my x-coordinate's positive and my y-coordinate's positive. And so to find this direction, this is going to be the arctangent of the, let's see, tangent of the angle would be opposite over hypotenuse would be y over x. And so this would be 245 over 297, right? I hope that's right. This should really be ringing the bells of Calculus 2. Remember when we did polar coordinates at the end of the semester? And I made you guys convert between the rectangular coordinates and the polar coordinates. And when we went from rectangular to polar, we had to use the arctangent of y over x. And sometimes you ended up getting an answer that was in the wrong quadrant, right? Whenever you use the arctangent function is only going to return values in the first or the fourth quadrant. So if you have a vector that ends up in the second or the third quadrant, you got to think really carefully about what the real angle should be, which usually involves like adding pi to get that. Okay. So does your calculator have an arctangent button? Did we figure out what this is?
It's 40 degrees. It's 39.5.
40 degrees? Okay. So that's the direction and magnitude of the resulting force. Does that make sense? What we did in this problem? Okay. This is a very typical physics class problem. At least I feel like I saw that a lot in high school. Okay. That's it for 11.1. And we're also going to try to make it through 11.2 today. So if you want to take a moment to copy down the homework problems for 11.2. Or take a picture of it, yeah. So I'm just really, really looking forward. But I want to say this. I really love my job. I love teaching. I really enjoy doing this. But I just feel like I have so much going on right now that like I'm so looking forward to summer. This is going to be like my first summer off where I'm not working or like doing anything or taking classes in like the last 10 years. And so this summer I'm really looking forward to napping and Starfield is supposed to come out in the first half of this year. Do you know what I'm talking about? The Bethesda game? No?
I'll search it up.
Nobody plays video games. Okay.
I'll try it.
And then there's the new Legend of Zelda that's supposed to come out in like May.
That is true.
There's it's called like Tears of the Kingdom or something like that. But
Oh, is it from Bethesda?
got a couple of games I want to play. Yeah, Bethesda.
Yeah.
Like they're the group that makes Fallout and Skyrim.
Yeah.
Yeah.
Crap, maybe
So
not.
Starfield's supposed to be like this RPG where you're like traveling the galaxy and I don't know. I hope it's good. I feel like Fallout 4 was horrible, but I loved Fallout 3, so I'm hoping this is good. Could go either way. Okay, I'm assuming everyone has copied down the homework problems. Okay, so we're going to plot these 2 points in three-dimensional space, and then we're going to figure out what is the distance between these points. And whenever you see like this, you know, we were used to seeing coordinate pairs where we have like the x-coordinate, comma, the y-coordinate, and plotting those coordinate pairs on an xy plane. So whenever you see 3 numbers like that, there's just this coordinate triple, and we can plot this in three-dimensional space. It helps if you are really good at drawing. And I'm just not really good at drawing. So here's my best attempt at doing this, okay? Just draw your XY plane like normal, and then you just have kind of like a Z-axis that goes through the origin coming out at you. My first point says 1, 2, 3. So I'm going to take 1 step in the X direction, 2 steps along the Y direction, and then 3 steps along the Z direction, and we're going to see where I end up. Okay? So here's 1 along the X, 2 along the Y, and then I kind of have to put like a point in the XY plane, and then I'm going to sort of try to move parallel to how I've drawn this Z-axis out to here, and then that's going to be my point, right? It's not a perfect system because, you know, you could be like, oh, that looks like 2 half 0, you know, like it's not perfect because I'm drawing on a flat sheet of paper, but that's the best I can do for that point. The next one is 3, -3, -2. So I need 3 steps along the x-axis, -3 steps along the y-axis, and then -2 steps along the z-axis. See where that ends up. So I've got 3, -3, and then I'm going to move 2 steps back along the z-axis, and so it's like there, kind of. But you have to have a really, really good imagination to believe that, you know, this green dot is a little bit forward out of the paper, it's coming at you, and the red dot is actually a little bit behind the paper, you know, because it has a negative z coordinate, so it's a little bit back from the flat plane. And like I said, not a perfect system. It's really hard for me to visualize it, but this is the best we have, right? Short of using MATLAB, this is the best we can do here. And so I want to know, what is the distance between these 2 points? What we're going to do is we are going to subtract these 2 vectors like this. So 1 minus 3 is -2. 2 minus -3 is 5. And then 3 minus -2 is 5. And so these represent the differences, right? So this vector is sort of like my difference vector. It tells me there's a difference of 2 in the x-coordinates, and there's a difference of 5 in the y-coordinates, and a difference of 5 in the z-coordinates between the 2 points that I was given. So I'll just name this vector lowercase d. And if I want to actually find the distance, all I have to do is take the norm of that difference vector, right? So this is going to be the square root of negative 2 squared plus 5 squared plus 5 squared. So somebody tell me, what is the distance between these 2 points in space?
Square root of 54.
The square root of
54.
54, yeah. Cool. And you can just leave it like that as your answer. So the difference between these 2 points in three-dimensional space is the square root of 54. That would be the answer to the question. I really, really, really want you guys to notice and appreciate something about this problem. I had to subtract one of the points from another point, right here. If I had changed the order of subtraction, I would have done 3, negative 2, minus 1, 2, 3, right? I could swap those vectors. If I had changed the order of subtraction, my difference vector then would have been positive 2, negative 5, negative 5. Would that change my answer? No. Yeah. That wouldn't change my answer because whenever you go to take the norm, you're going to square all of those anyways. And after you square it, you sort of forget the negatives. So it really doesn't matter what order you subtract them in. You could have swapped the order of subtraction. We still got the right answer, okay? And that's what you should expect from finding the distance between 2 points, right? Okay. Now let's find the equation describing a sphere with the following 2 points as endpoints of a diameter. So this is my very three-dimensional perfect sphere. And so what it means by diameter is it means I'm going to draw a line from a point along the sphere through the center of the sphere, and the line segment's going to continue until I hit the sphere on the other side. And so one of these points is going to be 1, negative 2, 3. And then the other endpoint of this diameter is going to be 0, 1, negative 7. Okay? How would I find the coordinates of the center of the sphere? What if I want to find the x, y, z coordinates of the middle of the sphere, the center of the sphere right there? How would I find that?
The midpoint of the diagonal.
It's just the midpoint between those 2 points I was given, right? And so the midpoint between 0 and 1 is 1/2. The midpoint between negative 2 and 1 is going to be negative 1/2. And then what's the midpoint between 3 and negative 7? Negative 2. So I just found the x, y, and z coordinates for the center of the sphere by taking midpoints of the x, y, and z coordinates of those 2 points I was given. Stop me at any point if any of this doesn't make sense or you need to clarify anything. Now, before I set out to answer my question, my question is asking for the equation of the sphere. I need to know the center of my sphere, and I also need to know the radius of my sphere. That's going to be pretty essential to finding a good equation. So, how do I find the radius of this sphere now?
Half diameter.
Yeah, it would be half the half the diameter. How do I find the diameter of the sphere?
What's the distance between those
Yeah, the distance between the 2 points I was given, that's the diameter of the sphere. So we're going to have the radius as the distance between my 2 points divided by 2. Okay. Now I'm going to find the distance between those 2 points the same way I did in the previous example. And so I have to take one of the points, 1, -2, 3, and then subtract the other point, 0, 1, -7. And my difference vector here is going to be 1 minus 0 is 1, -2 minus 1 is -3, and 3 minus -7 is 10. Then I have to take the norm of that difference vector. So I will take the square root of 1 squared plus 3 squared plus 10 squared. Which means the norm of my difference vector is 1 plus 9 plus 100, so it's square root of 110. Okay, so I'll take square root of 110 and then of course divide that by 2 to get my radius. So my radius is root of 110 divided by 2 for the radius of my sphere. Now, at this point, I know the center of my sphere and I know the radius. It would be good to know the formula that gives a sphere in space. And that formula is this. We're going to have x minus x naught squared plus y minus y naught squared plus z minus z naught squared equals r squared. Okay. So maybe you remember from algebra class the formula for a circle. This is the same formula, but we just add an additional term for the z coordinate. Yeah. Okay, so this is the formula for a sphere, where of course r is the radius, and we're saying that the center of the sphere has coordinates x naught, y naught, z naught. Okay. So for us, our formula for this sphere is going to be x minus 1/2 squared plus y plus 1/2 squared plus z plus 2 squared equals 110 divided by 4. So like 55 over 2. And that would be the answer to this question. Can everybody see this? Did I write it large enough? Okay, so I want to go ahead and just graph this and make sure that we did our work correctly. And of course, you can do this when you're working on your homework too, if you want to. There's a website called GeoGebra. I assume that's how you pronounce it. That's where I'm going to go to graph this. I'll use MATLAB if I want things to look really nice, but if I just want to do something really quickly, I'll use GeoGebra. I honestly don't like this website very much, But like I said, if I'm just trying to make something fast, I will sometimes do this. So you do the calculator, and then you do 3D calculator, and then we type in x minus 1/2. It's basically like Desmos, except it's really not user-friendly, in my opinion. Y plus 1/2 squared plus z plus 2, plus 2 squared equals 55 over 4. Okay, so there's my sphere. And I'm going to try to check my work by just plugging in these two coordinates. 1, -2, 3. Looks like we already made a mistake. And then 0, 1, -7. Oops, so this is not the right formula for that sphere because you see the A point sitting out there not doing anything. It's not on the sphere like it should be. And then the B is also not where it should be.
Negative parentheses on the first part of the equation.
Yeah. Oh, should be 55 over 2? Maybe that's it. There we go. Okay, so if it's 55 over 2... Oh, and that's what I wrote down anyways. I just didn't type it in correctly. So if you do actually the right radius, 55 over 2, then you can see that A is on the sphere, and if I can get the camera angle to work right, I can show you B is also sitting on the surface of the sphere right there. Okay, so it looks like we did the problem correctly.